All right, hey, PreCalc. We're going to go with part 2 of the notes for section 8-1. And I want to demonstrate, and this happens all the time. It can be frustrating. Sometimes you try something and it leads to a dead end. You have to sort of cross it out, go back to square one, try it again. And I did that the first time I did this video. In this case, once I got done with it and did all this and it came out to be cosine squared, I thought, maybe there is an easier way. So if you're looking up here and you're trying to think of a different way, maybe one or two kids in the class was thinking like, man, I would have tried something else. You could just simply switch out cotangent squared with its quotient identity. Cotangent is cosine over sine. You just got to square each one. So cosine squared theta divided by sine squared theta. That replaces cotangent. And then, let's get another color here. With cosecant squared theta, I could use cosecant. Where's that? Cosecant, I could use the reciprocal 1 over sine. I just got to make it squared. 1 over sine squared theta. You might think, Mr. B, that looks worse than it was in the beginning. But hold on a second. It's a fraction divided by another fraction. And what I can see is the sine squareds are going to line up. So if you took this idea and we took the top fraction, cosine squared theta over sine squared theta, and we multiply by the reciprocal. When you divide fractions, multiply by the reciprocal, sine squared theta over 1. And there might be a few kids right now going, oh, I see it. The sine squareds, whatever that fraction comes out to be, those two are going to cancel out. And you're going to end up with cosine squared theta over 1, which is cosine squared theta. It's the same simplified answer. All right, same answer in either one. This one I'm using a different identity, but it ended up with this answer. This one I just used a couple of fractions. I think this one might have been easier. And we ended up with that answer. So, as different kids look at this stuff, they could have different scratch work along the way. So make sure that you could show the properties. The answers are not going to be like what you're graded on in this stuff. That's going to be really the difficult part for me. Is I got to follow your steps, and I got to follow it step by step by step. It can be kind of tedious on my end in order to do that kind of stuff. But you guys have got to show your work. Like, you can't just tell me at the end it's cosine squared theta. You wouldn't get any credit for that. You got to show how you got the steps to get to that point. All right, this is all about the steps and stuff like that. So in example 2, in looking at it, I can see it's got sine theta here and here. Sine theta times cosine squared and times sine theta. So I'm going to treat it like if I had 4x plus 6, the 4 and the 6 both can be divided by, I can take a 2 out. I get 2x plus 3, take a 2 out. So what I'm going to do is take a sine theta. I'm going to factor it out. Sine, just working just like algebra. So this would leave me with cosine squared theta minus 1. Now we're getting somewhere. So what that means is cosine squared theta minus 1, I could take the property from the other page, sine squared plus cosine squared equals 1. I could probably make it look like this. Well, I can make it look close to that. It's going to be a little bit ugly here. I need it to be 1 minus cosine. So if I subtract cosine, it'd be 1 minus cosine. It'd be the other way around. So what I'm going to do, I got to get it to look like this. Yeah, let's subtract sine squared theta and subtract the 1. And I get cosine squared minus 1 equals negative sine squared theta. So there's my switch. Cosine squared minus 1 is equal to a negative sine squared theta. So this will be replaced That's not real pretty, but it's like a negative 1 times a 1. You get a negative in front. Sine times sine squared is sine cubed. That's not a property. But I get negative sine cubed theta. And that's what it looks like all simplified. try example 3. Let's see, sine theta. So it doesn't look like I can just factor out something as simple as what we did before. So what I'm going to do is take cotangent and put in its fraction. That's cosine theta over sine theta and cosine theta. Let's make it times 1. Cosine, or not times 1, but over 1. I said times 1, over 1. So if we actually multiply these two parts together, I would get sine theta plus this fraction, cosine squared theta over sine theta. And you look at that and you go, I don't know, I kind of stuck now. What do we do with that? What I'm thinking is, let's make common denominators. This is over 1. The common denominator would be sine. Right? This one has sine. This one just has a 1. I'm going to multiply sine theta, top and bottom. Multiply sine theta. Get a common denominator. Sine times sine is sine squared. Sine times 1 is just sine theta. This is cosine squared theta, sine theta. Now we're getting somewhere, because if I combine like terms, if I add the common denominator, I get sine theta on the bottom. And this is sine squared, cosine squared. That's going to give me a 1 over sine. All right. Remember the property, sine squared plus cosine squared equals 1. We're going to switch this out. That equals 1. Pythagorean identity. 1 over sine, that's the same as cosecant. So this big mess at the top, after all the scratch work, that's why you got all that space in there, is going to equal cosecant theta. Cosecant theta. We could do factoring. We could do factoring just like what we did with, in Algebra 1, Algebra 2, especially Algebra 2. So this is something squared minus something. You had x squared minus 1. I asked you to factor it. You would say x plus 1, x minus 1. I almost said perfect square trinomial. I think that comes up later. This is difference of squares. Difference of squares pattern. So if I have secant squared x minus 1, all right, I don't want to replace it. There probably is a replacement, isn't there? If I subtract 1, secant squared, it could be replaced with tangent squared. They're not asking us to do that simplify stuff. It flat out said factor it. So don't replace it with tangent squared. They want us to factor this. Secant x plus 1, secant x minus 1. Now it's factored. And that's it. That's all I want you to do. But picture it could be like set equal to 0, set them both equal to 0 and solve. That's what we're going to do late in the chapter. Late in the chapter, not this section. All right, factor this one. If I got 4 tan squared x, so they're both tangent. So because they're both tangent, I could think, well, what if it said 4x squared plus x minus 3? Well, I could do product sum. Negative 12, multiply to be negative 12 and add to be 1. That would be 4 and negative 3. So that would be like a 4x and negative 3. 4x minus 3 and x plus 1. That would give me 4x squared plus 4x minus 3x. Yeah, that would work. So I'm going to use this factoring idea, and I'm going to use this. So it's going to look like 4 tan x minus 3 times tan x plus 1. And now it's completely factored out. Factoring doesn't go away. I know some of you guys cringe because you never mastered it in Algebra 2. It doesn't go away. You got to know how to do the factoring stuff. Ooh, this one's kind of tricky. So unlike this one both had tangents. This one's got a cosecant and a cotangent. Oh, but from our Pythagorean identities. Hold on. let's go back. Cosecant squared, you could replace that with 1 plus cotangent squared. Cosecant and cotangent squareds have this identity when they're squared. 1 plus cotangent squared. All right, so I'm going to take this and I'm going to replace it with 1 plus cotangent squared x minus cotangent x minus 3. All right, let's rearrange this a little bit. 1 plus 1 and negative 3 make it a negative 2. Cotangent squared, we want that first, and this is in the middle. So think product sum, just like now we got them all cotangent. We can do factoring like we did over here. What two numbers multiply to be negative 2, but when you add them together is negative 1, and it's going to be negative 2 and positive 1. So real simple, it's going to be cotangent x. So you would think x minus 2 and x plus 1, because it's a 1 in front. It makes it a little easier than this one. That one had a 4 in front. So it's cotangent x minus 2 and cotangent x plus 1. And those are your two factors. Now, don't try, when it says to factor it, don't try to do the replacing right off the bat. Like this one, you could have made tangent squared, but then there wouldn't be any factoring involved. If they want you to factor, you got to factor it. The only trick to that is they all got to be the same trig ratio. So this one I did have to change cosecant squared so that they all said cotangents, and then I could do factoring. That was the only tricky one that they threw in there. This does take a little patience. It does take a lot of trial and error in the beginning to sort of get the hang of it. Every year, kids feel like nervous when they get into this thing. So stick with it. Ask questions when you got them, but most of all, don't shut down. It'll make the rest of this chapter impossible if you don't try these early ones. These are considered the easy ones. They get more complicated as we go along. So it's brand new, whole new idea, way of thinking. Might blow your mind for a minute here, but stick with it. Keep practicing it, and you'll get better at it.